We're going to continue our discussion about the architect's role on a building project by picking up where we left off in the last lecture. We had discussed the previous few phases at the beginning, selecting the architect, and then moving into pre-design and then schematic design. And once the scheme has been decided on and approved by the client, and the architect and the client are in agreement, then everyone moves on to design development. Now you can see on a project that it's a process. We keep talking about this idea of it being a process, and there are different phases throughout the process. And without going through these proper phases, the building is probably going to either miss something or not everything will be checked accordingly. So these are fairly prescribed phases, and it's because the project needs to develop over time, and it needs to be checked and verified that everything is going to be structurally sound and compliant with codes and useful to the user. And so there are all these different facets of the design of the building that we need to look at. And you'll see throughout this process that it's progressive, meaning in the early stages you have some initial developments of the mass or the overall volume of the building or the structure or complex or whatever it is, and then we keep adding to it, keep refining it and putting it through a process in which hopefully it just keeps getting better and better. And also it becomes more realistic, it becomes more refined, and this idea that when we move into design development, there is a level of acceptance of the scheme, then we can kind of move on as the architects and as the owner and really start to add a lot more information. The design development phase is exactly what it sounds like it would be. You're taking the design that you came up with in schematic design and you're further developing it, meaning you're going to introduce the different building systems, you're going to select all the materials, you're going to put more realistic parameters on it so that as you do this, that if there are things that need to shift around design-wise, that will all happen in this phase. So ideally that when you're done with design development, that design has stopped. Now most architects I think would say that design is always continuing on, and that's probably what drives contractors and also clients crazy sometimes, is that architects are always trying to kind of refine each particular detail and make it better, but at some point, hopefully at the end of design development, that is all kind of tightened up, and that there's not a whole lot of movement on the design side that happens after this. So let's take a look at what happens during design development. So one thing that happens is the selection of building systems. And building systems can be anything from the mechanical systems, the electrical systems, the solar systems, the materials, all different kinds of things. And if you think of a building as a series of systems, then you can start to understand that there are many different systems in play. So here we're looking at kind of a perspective section cut, meaning there's a cutaway of this building and you can see the multiple floors. This is showing some heat diagrams and what's happening with the sun, or what we'd call solar heat gain, and how there are different collection systems for water, for example, and then what's happening with the air conditioning and some of the ventilation and heating. And if you think of a building, not unlike the human body, if you have the circulation system, you have the heart and veins and arteries and blood, all is kind of one network. So, on a building, if you have the heating, ventilation, air conditioning system, then you've got all of these parts and pieces of that, which is, the ductwork and the outlets in each of the rooms that let air in and out. You've got the equipment that's attached to that. That's all part of one system. So a system means it's not just one part. It's a, grouping of similar parts that perform a certain function. So in a building like this, you would have the mechanical systems, meaning all of the heating, ventilation, air conditioning, and then other mechanical parts, like if there's an elevator or an escalator, you've got moving parts and motors and, power that needs to be generated and provide service to those things that move around. Some of those we'd call conveying systems, like if you are moving parts up and down and moving people around, like in an elevator, that's a conveying system. Or you might have the electrical system that provides power throughout the building. And part of the electrical system would be not only the switches and the outlets, the things that we see in the rooms, or the light fixtures that we see in the rooms. Obviously, those are all connected, and they're connected by wires. But also the way in which the building receives power. So is there a central location where the power source goes into the building? Does it come from a city or community source? Does it come from solar power that's attached to the building? Does it generate or retain power or maintain power in a certain way? And what is all the equipment? Are there panels that are associated with that? Where do those go? Are they down below in some kind of electrical and mechanical room? Those are all part of a single system. So you're constantly trying to think of this in terms of, what's happening with this particular building system. Even the exterior materials and interior materials are all part of a building system. So when we talk about material selection, you might be talking about multiple materials that come together and form what we'd call the envelope of the building, or the exterior of the building. So does that include, as in this photo, high performance glazing? That just means high performance glass to try and mitigate a lot of heat gain that would potentially come in through those windows. There are also solar shades here to try and block the same type of thing. So all of this is part of the building system selection, and it's a huge process. So in design development, if you look at your scheme in schematic design, even if you have floor plans and elevations and section drawings, some two-dimensional drawings, and even a three-dimensional model, it can look like a building and have mass and volume like a building, but until you start to select all of these building systems, it doesn't become realistic, and it's not even close to becoming buildable. So the goal is for this to be buildable eventually, and this, again, is all a process, and so you're doing a lot of exploration of different building systems in design development. And sometimes you even start to run analysis through 3D digital modeling to try and predict how the building might potentially perform. Like if you select a certain type of glazing and you want to see, is that really going to prevent heat gain from coming in, you can start to run some predictive calculations if you have a digital model, or you're working with other people to try and figure that out. So the people that the architect works with to explore all of these building systems and various other issues on the project are referred to as subconsultants. Sometimes we call them just consultants, but the idea is that the architect is not the only person working on this project. And even when we refer to the architect, really it's almost like a plural term because it's never going to be just one person. I mean, maybe it is, if it's a very small project or maybe a residential project, but typically we're talking about a whole company of people that is working together on a project, and it's extremely collaborative. That's why when we talk about that idea of the starchitect, that they have hundreds of people typically supporting that effort, and usually it's a large firm, and there just happens to be kind of one face or one name that we associate with that firm. But usually it's a large group of people, or at least a group of people that are highly team-oriented and are communicating and working with one another to try and figure out the best solution and schemes possible for this particular project. So when the project is going through this process and going through these phases, once the architect is hired by the client, sometimes even in the initial phases, the architect and the architecture firm is trying to consider who might potentially be the best consultants or subconsultants for this project. Now, a lot of times you'll tailor who you select to be on the project team to whatever that project requires. So the project team is the architects and whatever subconsultants are hired by the architect. And the reason why they're hired by the architect is kind of for the flow of information and point of contact between the client and the architect. So the architect is really the voice of the project for the client, so that the client isn't getting direct calls from the structural engineer saying, hey, what do you want here at column A1? And the owner is saying, well, I don't really know. So that all gets filtered through the architect. So the architect is the sole point of contact typically for the client, and then the architect disseminates and filters all the information necessary in the project out to all the subconsultants. Then they do their work, and then the architect gets all of that work back and then enters into what we call coordination. And the idea of coordination is that the architect has hired all of these different people to be part of the project team. And, there are lots of different people who might potentially be on a team, and, often we start with kind of the main ones that seem to be on most projects. Structural engineer, and we refer to this as a single person, or it sounds like a single person when I say structural engineer, but really we're usually referring to a company or a firm, an engineering firm that gets hired by the architect. So it's like an architecture firm is hiring an engineering firm to perform a certain amount of work on this particular project in a certain amount of time and for a certain amount of money. And so because of that, because they're hiring them, the subconsultant and the architect sign an agreement with each other. And that's why we say subconsultant, is because the architect is hiring all these people to serve as different specialists on the project. So there might be a structural engineer, a civil engineer, a mechanical engineer, an electrical engineer, and the list really just keeps going. So you could have a landscape architect, an interior designer. You might have an acoustical engineer, a transportation engineer, lots of engineers, obviously. But then you might also have a specifications writer. You might have a programming consultant to come in at the beginning and do research and write the program. The list really kind of goes on and on. But we're talking about the design side of the project. We're not talking at all at this point about the contractor and the people who are hired by the contractor to build certain things. Sometimes we'd refer to those as subcontractors, but that's not what we're talking about. We're talking about subconsultants that are all on the design side of the project, working through the issues of design and documentation. So once these subconsultants or consultants get hired, they start taking the architect's scheme from schematic design and running through a series of tests and creating their own drawings based on the architect's drawings. Maybe they're creating 3D digital models based on the architect's digital models. And so there's a lot of information that goes back and forth, and there's a lot of information sharing. So the idea of coordination means because they are all hired by the architect serves as kind of the central collector of all this information. So they collect information from the client and they give that out to everybody on the team. So they might say to the structural engineer, okay, this client really prefers this type of material, and maybe it's steel. Maybe they really want a steel and glass building. They like the appearance of it, the functionality of it, whatever it might be. And so then that gives the structural engineer some direction. They start designing their columns and beams and everything else in steel. And then, they'll start doing load calculations and, figuring out if what the architect has put together, how best for that to be able to stand up and be structurally sound. And then once they're, getting closer to the end of design development, they will give their drawings and models back to the architect. And usually they'll give them back, some amount of time before the design development set is actually due. When we say set, it means like all of the drawings and models associated with that. And then what the architect will do is they will coordinate all of that information. They'll take all of the models and drawings from the structural engineer, mechanical engineer, civil, all of that, and they'll put them together and they'll start to see if there are conflicts. Now sometimes they can do this with the help of some digital software where they can take models and drawings and put them together and see if there are clashes, or what we call clash detection. But most of it has to do with the architect being aware enough of every facet of the project where they can look at different things and say, this beam is in the same location as this piece of ductwork that the mechanical engineer has. So we need to coordinate that, meaning we need to talk to both of them and see if one or both of these things can move so that they're not in conflict. And it's really the architect's job to do coordination. And it's a huge job. So usually they'll ask everyone for their drawings and models, maybe a month or a few weeks before the actual deadline of design development, when that's anticipated to be completed, and then they'll run through all those changes. And if anybody else needs to make changes to their drawings or models, which they typically do, then they have enough time to do that, and then you get what we would refer to as a fully coordinated set of documents. Now, one of the other things that happens in design development is a revisit of the cost estimation process. So maybe in the end of schematic design, there was an initial cost estimate that was done just to make sure that things were generally on track as far as budget goes. But since you're introducing all these building systems, it becomes a lot more realistic and therefore a lot more specific in terms of cost. So it's a good idea to do another cost estimation during design development so you can see if the building is still on track budget-wise. Now, what usually happens is something called quantity takeoff. And again, if there's no contractor on board yet, then a third party consultant might be hired as the cost estimation consultant. There are cost estimators that you can hire to review all of the documents that you have and see where you are in terms of cost and budget. But the idea of quantity takeoff means the cost estimator has a certain number money-wise for how much each item of the building costs. So in Austin, you can, kind of get an estimate for what a certain type of roof material would be, roofing material. And you could say, okay, I know that this roofing material costs this amount of money per square foot. And then if I look at how many square feet I have in terms of roofing, then we're going to apply that as a line item in the budget, and then we get that number. Now, roofers typically refer to the number as a square, and it's 100 square feet. So every 100 square feet is a certain amount of money. But when we're looking at this, each individual material is going to have its own quantity takeoff and its own estimate of cost. And when you get the entire cost estimate back, it's basically adding up all of those individual line items of materials. And at the design development stage, it's actually helpful to see this, because if you look through the list and you see one that seems extremely large, it could be something that as the architect or engineer you might not have thought was a really expensive material, but for whatever reason it's currently running more expensive than normal. Then that's a chance for you to swap out that material for a different one during design development while you're still making those design decisions, so that you don't get to the end of the process in construction documents, then you realize you've designed your whole structure and your whole scheme around something that is just going to be too expensive. One of the other benefits of doing a cost estimate or cost estimation in design development is that the owner is able to see how much each individual line item is going to cost, or how much it's estimated to cost. And if they had their heart set on one certain material, and then they see it's going to be 5 times what all of the other materials are going to be, and that the project is over budget by that amount, then they might be more motivated to potentially pick another material, or maybe look at redeveloping that particular aspect of the project. And so it's helpful just in terms of information that everyone have that early on in the process. Now, when we talk about deliverables, remember deliverables are things that you're going to produce as the architect during that phase, and usually at the end of that phase, because during that phase you're working toward that goal. And especially when you're hiring consultants, subconsultants, that's the same thing, consultants and subconsultants. But when you're hiring them, you're giving out information and meeting with them and constantly going back and forth with their drawings. So usually the targets that we talk about with deliverables are at the end of the phase, so that those things can be produced and finished and completed, kind of wrapped up in a fairly neat package, and then everyone can see kind of where the project is at. So you do that at the end of schematic design, and you'd say, okay, here's everything associated with schematic design, all the drawings and everything else. And then when you move on to design development, then the next deliverables would be at the end of the design development phase. And because this is a progression, we're not saying that these are the only things that you would deliver at the end of design development. This is in addition to all of the things that you did in schematic design, but you would have revised all of those things in schematic design and then added these items to that. So, before you even get to this list, you're going to have revised floor plans, revised elevation drawings, revised section drawings, revise 3D models and renderings, and then you're going to start to add in these other things that are going to be more realistic and address the things that have been starting to be worked out in design development. So things like outline specifications. Specifications are written documents that describe all of the materials used on the project. So a lot of times people will say, well, that seems a little bit redundant because aren't we showing that on the floor plans? Aren't we showing that on the exterior elevation drawings or on the interior elevation drawings, which are basically just the exterior and interior vertical views of the project? And the answer is yes and no, because the plan and the two-dimensional drawings are really meant to show the location of objects and the measurement and the dimensions and the placement of objects. But if we really described every material in detail that was used on the project, every drawing sheet would be completely covered in notes. And so what ends up happening is the specifications are a series of written, kind of long-form written documents that in great detail describe each material and the installation of each material and really the quality that we want to maintain as the architect throughout the project. So it's a list of kind of material instructions that are ultimately going to be used by the contractor or whoever is building it, so that everybody is certain as to what the level of quality is with the material selection. And then we'd start to add in things like interior elevations. Those are just interior views that are vertical views, as if you're standing inside of the building looking around at various walls inside. Interior schedules, and by schedules I mean they almost look like spreadsheets of different types of information. So when we say interior schedules, you would start listing out different walls, and you'd say, okay, the north wall of this room inside is going to be painted sheetrock, or the east wall of this room inside is going to be wood paneling or glass or whatever it happens to be, so that people are more clear about how the materials are taking shape realistically on the building. We'd start looking at details, and those are just drawings where we look at the connections of different parts of the building. So how the wall connects to the floor, how the floor connects to interior walls, how the exterior walls connect to the roof. And so we're starting to think more about that instead of having these just generic volumes or these generic masses that aren't really addressing real construction. And then obviously the SubConsultants drawings, everything that they've been working on. Hopefully this is a fully coordinated set of design development documents. And then also revising the drawings that were produced in schematic design and revising all the renderings and 3D models. That's always helpful for the client and the owner, because especially if there are multiple people on the owner side, maybe there are multiple users that are going to be using the building, they can all kind of stay informed by seeing what the 3D options or the 3D renderings are going to eventually be and what the building's eventually going to look like. And then a revised cost estimate, as we had discussed. And this list is not comprehensive necessarily. This might expand or contract based on the type of project. The bigger the project, the longer the list of deliverables probably at each phase. And so this is just kind of like a general, almost like a rough outline of what you might potentially have in addition to revising the things that had been developed in schematic design. And then the next phase is the construction documents phase. And construction documents is typically the longest phase of the project. We think, okay, well, we're getting closer, right? We must be almost done. But when we talk about construction documents, and you can see from this drawing, or this series of drawings, this is the High Museum of Art in Atlanta, and the reason why construction documents take so long is because it's like creating a series of instructions for building it. And if you look at either a schematic design set or a design development set, and you really ask yourself, is this a series of good instructions for somebody to be able to build that? And typically the answer is no, right? I mean, there's some information there, but if somebody picked those up and stood out on the job site, they probably wouldn't even know where to begin. And so construction documents starts to address, okay, are we showing as a project team all of the different scenarios that somebody is going to need in order to construct this? And so that's when we start looking at all these cutaway sections of walls and different details and connections in the building, showing all of the dimensions, showing all of the materials, all the places where you have framing and insulation and glass, and exactly how far everything is spaced apart, and not just in one certain area of the building, but everywhere. We can start looking at different cuts and sections and details, but if we haven't kind of thought of that holistically and applied that logic to the entire building, then we're not going to have a fully formed set of instructions. And part of how you become aware of what you should show in construction documents is almost going through the building mentally and saying, okay, what order is this going to be built? So maybe they're going to start with the foundation, and you say, okay, well, do we have all of the drawings and models necessary to show someone how to build the foundation? Are there enough instructions for how to build the foundation? And that's not just the drawings, that might include the specifications, that written document with listing all the materials. That's all a critical piece and part of creating these building instructions. Now, at some point, the architect and the whole project team is creating these instructions for building this project. But the contractor is the entity or the one who has to execute it, right? And so, you might not go to the extent of saying, okay, you need to put scaffolding here in order to lift this piece of the building into place. But you're going to be the one that says, this piece of the building needs to attach to this other piece of the building in this way. So if you have instructions that are clear, then the contractor has the flexibility to build that the best way that they see fit in the most quality way possible, while still meeting all of the quality standards and the controls that were set in place by the drawings, the models, and the specifications made by the project team. Another way that we look at this idea of instructions for building is, on the architect side, putting yourself kind of in the mind of not only the contractor, thinking of the contractor as a single entity, but thinking of everyone who's going to work on the project. So if there's a glass installer, have we provided all of the individual instructions for just the glass? So we see on this project, it's a concrete frame, and the structure is concrete, but then there are all these glass pieces that need to attach to the exterior to kind of form the envelope or the skin of the building. And without the glass, it's not enclosed, it's not functional, but with the glass, it starts looking like an actual building and starts to become realistic in that it's enclosed, it can be heated and cooled. But if that glass is not attached properly, or it's not, designed properly or spelled out in the specifications properly, then, pieces could fall off, or it might fail, or it might get too hot, or, all different kinds of things can happen. So you start to look at it piece by piece, and that's why that idea of thinking of it in terms of building systems is helpful also, because you think, okay, is this system working? So is the glass or glazing system shown or documented properly, and is it going to work properly? And so you're trying to predict that as much as possible. Now, when you are writing specifications, some of this might be done by the architect or the architecture firm. Some larger architecture firms have specifications writers on staff, but some don't, and will hire specifications writers as subconsultants. And the better the specifications writer, the better the project is. And it can be a pretty intensive process, because it's almost like a legal written document where you want to make sure that it's concise and clear, and yet includes all of the information that's required for the project. So you don't want to leave stuff out, so that if you do leave things out, then that might be open to interpretation on the contractor's end. But you also want to make sure that it addresses issues of quality. So an example of this might be, if I have a bunch of windows on a project, and I specify that I want this certain manufacturer to make the windows, or I know that there's a certain model number and manufacturer of the windows I want ordered, then I need to put that in the specifications. I need to say, okay, I want Pella windows, and I want this model number and this stock paint finish that they have. But if you're not totally committed to one particular manufacturer, but you just want a certain size of window and a certain material and finish, and you're going to leave it up to the contractor to pick whichever one they want, you can do that too. So one way of writing it would be what we call prescriptive. So prescriptive in writing specifications just says, here's what I want, and it's up to the contractor to find a manufacturer that can fulfill that particular request. But if it's proprietary means that you know exactly where you want it to come from, the manufacturer, the make, the model number, the color, and you will not accept anything except that particular brand in that particular style. It's almost like saying, okay, I need a tissue, but some people might say, I need a Kleenex brand of tissue. That would be proprietary. But if someone says, I just need a tissue, I don't care if it's Puffs or Kleenex or HEB or whatever it is, then that would be prescriptive. And so you kind of go back and forth, and you can mix different sections, different materials in building systems. You can mix either prescriptive or proprietary specifications depending on what it is. So it's not like you have to pick, all the manufacturers on all materials if you decide that's the way to go. Maybe it's just that you care more about some things than others, or on some things it doesn't matter. Like if you're pouring concrete, there's not like a concrete pouring truck, I guess, that you get off the shelf at Home Depot. That's something that has to be done customized on site. So then instead of writing a proprietary specification, you would write a prescriptive one that says, okay, when you pour the concrete, it needs to be this temperature outside, and the ground shouldn't be frozen, and it should be this mix, and all this kind of stuff. One of the other jobs of the architect is to work with manufacturers and fabricators. And when we talk about that in construction documents, you might say, well, wait a second, it's not being built yet. And no, it's not being built yet. But eventually, if you have a highly customized piece of the building that you're working on, you can't just wait until construction starts and then say, oh, by the way, we want this massive metal panel that looks like a butterfly or a bird like this guy is working on. You need to be working with a specific fabricator probably on the construction documents end so that you know that they can do a certain thing that you want to do. And they might have certain fabrication processes or manufacturing processes that they adhere to that's going to help you design something better and that can be realistically produced. We see this a lot where you kind of go back and forth with specific fabricators and manufacturers, and this might be on more customized or kind of larger scale projects. But if you know that there's going to be something customized, then you need to have, start working with fabricators in mind before you get to construction so that you can inform the contractor and you can include those types of requirements and things in your drawings. Some of the construction documents, deliverables that you might include are site plan, floor plans, elevations, and sections. And keep in mind, this is everything that you're going to need to build the project or that somebody's going to need to build the project. So it's basically any and all of those building instructions that you're going to have. That might include wall sections, details, interior elevations, reflected ceiling plans, which basically just says, okay, we're making plans of the ceiling, and schedules, which means kind of these things that look like Excel spreadsheets that have information about the materials and different objects on the projects. All of the SubConsultants drawings fully coordinated, and the specifications fully written out and addressing all of the materials on the project. And this list is certainly not exhaustive. I mean, it will probably be a lot longer than this, especially when you consider that every project is going to be different, and every project is going to require individual or customized drawings, details, and models that talk about what's going to be special or specific on that project. So for example, if you were working on a theater, you're probably going to have a bunch of acoustical drawings that show different panels that will help with the acoustics, or maybe there are a series of lighting drawings and things with the stage and curtains that you wouldn't have on another project. And if you were doing an airport, then you probably have all these different mechanical pieces and parts that have to do with, moving baggage throughout the building and moving people throughout the building and moving airplanes in and out. And so each project is going to have its own specific set of requirements. Now, I put contractor selection here after construction documents are done. This is kind of in a traditional type of project delivery. You may have contractor selection occur earlier in the process than this, but if it's going to be put out for bid, we would say, then that probably won't occur until after construction documents are complete. So there are a couple of different ways that, there are several different ways that contractor selection could occur, but one of the ways is by bidding. And so this goes back to that kind of traditional method of project delivery called design, bid, build, where the project team, including the architect and all the engineers and all the subconsultants, they design the building and document everything and produce the construction documents, and then contractors, multiple contractors, are invited to bid on the project. And so what will happen is they'll get copies of all of the drawings and specifications, and they have a certain amount of time where they can review it and look at it, and then they come back to the owner with different proposals that say, okay, I can build this building in this amount of time for this amount of money with these different parameters, and then they, kind of sign off on it. And what that allows the owner to do is compare all of these different proposals and select from one of them. Now, in a public project, a lot of times if you're using public funds, you might be required to use design, bid, build, because there may be some legal requirement that states that you're required as a city or county to accept the lowest bid so that you're using the least amount of money. Some other larger corporate or institutional clients might use the bid process, but that's essentially what we're talking about, is bidding on the construction documents that are completed and making proposals on the contractor side for what could happen. And then the owner selects one from those bids. Now, the other way that you might hire a contractor is by negotiation. And that just means, you go through almost like in architect selection, where you have a list of contractors that you potentially approach, and instead of having everyone kind of pitch these bids to the owner, that you go through kind of contractor by contractor, and you look at different ways in which they could meet the schedule obligations, the money and budget obligations, the quality that you're seeking. And the owner might also structure their fees with the contractor, where you might say, okay, I understand that you're going to build this for this amount of money, and maybe we say there's a guaranteed maximum price, and then, we're not going to pay over that. If you go over that cost-wise, then you're going to absorb that cost as a contractor. Another way you might structure it is if the owner is really motivated to get something produced on a quicker schedule, you might offer incentives to the contractor for hitting certain targets or certain time deadlines. If time is not an issue, then maybe you don't have that in there. But in the negotiation process, the subcontractors, or the people that the contractor hires, are going to kind of give them bids, and then they're going to get an idea of what each subcontractor is going to charge. And don't get this confused with subconsultants. Subcontractors are the individual installers that are going to work on building different parts of the project, and they are hired by the contractor. So they'll give the contractor prices, and then the contractor will get an idea of the overall price that is going to be required that they'll have to pay out. Then they'll figure out their overhead and profit, and then they negotiate a price with the owner. Keep in mind that the architect typically assists in this process, but they are not involved in the agreement signing between the contractor and the owner. The owner and contractor sign an agreement with each other that is typically not involving the architect. Permitting is another part of the process in which the architect assists, but potentially the contractor is the one applying for the permit, but the architects assist because they're preparing most of the documentation that's required for permitting, like all the drawings, all of the individual sets, checking for code compliance, zoning compliance, things like that. But usually the builder or the contractor is the one actually submitting the application, because whoever submits the application is going to be the one that calls the city or whoever's checking on the permit periodically to get inspections. So whoever's building it, as they go through the process of building it and documenting, its construction, then periodically they're going to have to call for inspections. And each one of those inspections will fulfill a certain requirement of the permit. And when a building project gets a permit, it will list out all of the inspections that are going to be required. So that might be a concrete inspection, framing inspection, mechanical, electrical, plumbing. And so it's the contractor's job, as each one of these phases of the project is built, that they call the city for an inspection. The inspector comes out, says, yes, that's okay, no, it's not okay, and then they need to pass each one. So usually that's why the contractor applies for the permit, because they're in the end going to be the one scheduling all these inspections. And then you see at the bottom here, especially for commercial properties, the certificate of occupancy is what you're trying to get when all of the approvals have been made on the inspection side and you're clear to occupy the project. The last phase of the project, where we want to take a look at the architect's role and the architect's involvement, is construction administration. Now, sometimes people are under the impression, perhaps, that the architect finishes their drawings, they finish all their models, they hand it over to the contractor, and they're done. But often, construction administration can be the most critical part of the architect's job or the architect's role in the project, and that is to oversee the construction in the sense that they're not the contractor. They're not, telling everybody what to do, but they need to observe what's taking place to make sure that what's getting built is the same as what they had intended through the drawings and specifications. So construction administration just means during construction. And this is not intended to be a phase where a lot of drawing or modeling or anything takes place. Hopefully that's sort of done, but there's often going to be small changes and small adjustments that need to be made throughout the construction process so that the building can address any issues that arise during construction and that the architect can address those. And hopefully, as those hopefully small changes come up, that the architect is also revising all the documents every time there's a change, so that when the project is done, that they have what we would refer to as built documents, meaning the drawings that you hand over to the owner in the end are the same as what actually got built, so that you don't end up with a set of drawings where you had made a bunch of changes but didn't make any of the document changes, and then the owner is left wondering what's different between the end of construction documents and the actual building that they now own. So when we talk about construction administration, we tend to look at ensuring quality. So quality control is really the focus, and you want there to be quality control on the contractor's side of things, but the architect's role in quality control involves going to the site, looking at photographs, just looking at everything during every phase of the building to make sure that what is in the drawings and documents is actually what's going up in the building. I think if you just said, well, I'm not going to look at anything that's getting built, you'd be pretty surprised at what happened in the end, because you'd probably go out to the finished building and say, what happened here? Why is this different? The contractor might say, well, we struck oil when we were drilling for the foundation, and then we had to move the building 50 feet over here, and then the structural system that you designed was no longer available or the manufacturer went out of business, and so we decided on this completely different scheme. Now that's an extreme example, but you can see how every little thing that might happen on the job site during construction can potentially affect the original design intent and the original material selection, and so the architect needs to be an integral part of the process in order to ensure quality and to control the quality. The other thing that happens is that you might even have, this is a third-party inspector where they're coming in just to check the equipment to make sure it was installed properly. Sometimes large-scale buildings will have this and the owners will want this because it will ensure that it was installed properly, and then warranties are in effect. You know, if something was installed improperly and you don't know about it until the owner moves in, then it might void the warranty from the manufacturer. So quality control is really a hugely important issue during construction. So the architect's job during construction involves visiting the site and documenting it through field reports. Sometimes you'll see this as the architect's field report or the architect's report. There are even AIA documents that are standard form field reports for architects to use. A lot of times they'll involve the architect taking photographs and including those as part of the field report. The architect typing up, actual notes. Maybe lists of items, maybe referencing parts of the drawing, maybe even, drawing sketches and scanning them and including that as part of the field report. But usually when we talk about the scope of work initially, the construction administration portion of the project is typically going to be addressed so that the owner doesn't get to the end of construction documents and say, okay, well, we're going to stop paying you after construction documents, so your fee stops there and doesn't really include any site visits or field reports, because it costs money for the architect to take time out and go visit the site. So usually everyone will want to include that as part of the original scope of work or the scope of services in the original contract. If it's not, then sometimes, at the beginning of construction administration, it might be written up in a separate agreement as part of additional services, but hopefully there's compensation for the architect by the owner to go out and do periodic site visits, and it helps things go more smoothly. The better the communication between the architect and contractor, the more smooth construction is going to be. So usually it'll be set out, at what interval the architect should visit the site. If they go more than that, that's fine, but there might be a minimum that says, okay, the architect needs to visit the site at least once a week. And maybe if they're out of town, maybe it's like once a month, but they get weekly photographs from the contractor. Or sometimes they'll have a job site video camera that's set up, and people can log in from wherever they happen to be and they can see exactly what's going on. So site visits are critical. Attending project meetings at the job site is critical so that the architect can be part of the status of the project. And usually it involves the owner or the owner's representative, the contractor, and the architect getting together and making inspections, and then just staying up to date, like where are we this week? What's going to happen this week? Do we have anything that is outstanding in terms of information that we owe you? And did we send you the last field report? So that everybody kind of stays on track and on schedule. The other thing that we tend to look at during construction administration, and sometimes you'll even see this start to begin during construction documents, but the architect is responsible for approving submittals, construction mock-ups, and shop drawings. And submittals are actual samples of either materials or some other object that's going to be used on the building. Now, you might think, well, didn't they say what that was going to be in the specifications? Well, yes and no, because let's say the specifications say, okay, on the face of this building, I want to use some gray limestone. And then, during construction, the contractor knows they're going to need to order some gray limestone that's going to be used in a month, let's say. And so they go to several suppliers or several quarries and they get a bunch of samples of gray limestone. Well, they might be 10 different shades of gray and different thicknesses and different textures. And unless, you called out the specific source or quarry where that was supposed to come from, then the contractor will probably send several different options to the architect. And a lot of times they'll either cut the material in two pieces or get two pieces of the same exact material. And they'll put a stamp or a sticker on there. And if the architect approves it, then they sign both of them, keep one, and then send it back to the contractor so that they have the matching submittals or the matching actual pieces of the material. So that when it gets built, and if the architect shows up and says, oh, this is not what I approved, and if they both hold up their same sample and it matches, they're like, oh, well, I guess that's the one I approved. So it saves a lot of hassle in terms of disagreements about what was approved, and also lets the contractor kind of keep going so that they can get approvals for materials and order them and keep going. Mock-ups typically refer to things that you can't just send somebody in the mail. Like if I've specified as an architect that I want to have a cast-in-place concrete wall, and I want it to be a really smooth finish, and I want it to be a certain color, and I want it to be, a certain pattern on the exterior. That's not really something that the architect or that the contractor can just whip up and send through the mail. They'll probably have to mock it up physically, or a small piece of it, or they might mock up like a few different versions and then have the architect approve one of them so that they know in the bigger version of the building what that concrete should look like. So there are mock-ups that need approval. And then there are shop drawings. So shop drawings are usually drawings that a fabricator or manufacturer draws based on the architect's drawings. But they'll do their own drawings because sometimes their manufacturing processes or the way that they detail things might be slightly different than what the architect had asked for, and they'll send the shop drawings back and they'll say things like, this happens like on cabinets or things like that, where they'll say, okay, you drew these cabinets this way, and based on the joinery that we make or the way that we manufacture these cabinets, we're going to have to do them slightly differently, but are you okay with this? And they'll draw it up. And then maybe the architect will make some little revisions or notations, and they'll stamp it and sign it and say they approved it, or they approved it with changes. They could reject it and ask for new drawings or different drawings, but usually it's kind of a back and forth process working through the shop drawing phase. And typically it's going to be during construction when the manufacturer and fabricators are involved and on site. One thing that comes up that is the architect's responsibility during construction administration is that if there was some either omission by the architect, or maybe it's just something that came up during construction that the architect needs to address, then the contractor will send a request for information or an RFI to the architect. And basically it's a question that they need a response to from the architect. Either a design question or a clarification. Maybe there are two drawings that are showing the same thing, maybe the same condition, but they're slightly different, or they have different dimensions, or they need clarification. Then they'll ask for an RFI. Now, When they send the RFI, usually they'll number them so that everybody can keep track of them. So they'll say RFI number 1 is what color is the paint supposed to be on stairwell number 1? Well, it's not going to change the cost of the project to paint stairwell number 1 because they probably figured in paint. It's just they're not sure what color it is. So the color, whether it's one color or another, isn't going to affect the price. It's just they need to know that. The contractor needs to know that in order to proceed. So request for information is typically just a request that will not have an impact on the overall budget or cost of the project. Now, usually the more RFIs there are on a project, either the more stalled the project becomes, or maybe the drawings weren't quite as clear, or maybe there were just a bunch of things that came up during construction. Maybe it's a kind of a difficult site to work with, and there were modifications that needed to be made. But ideally, you would want, as the architect, fewer requests for information because it means construction is kind of going more smoothly. A change order is a request that needs to get approved by not just the architect but by the owner, because typically it involves a change in price. So on this form you can see where it says original contract price, and then the amount of previous change orders and the adjustment for this change order. Now, I would like to say that it means that they send these change orders to the architect and client and they say, oh, look, we saved you $5,000 this week. But that's not usually what happens. Usually it's something like, well, we struck oil and now we need to revise the structural slab because it's got to float kind of over this pool of oil that we're sitting on. And so we need this additional money in order to make that happen. Or it could even be that when they did the original cost estimate, maybe a certain material cost a certain amount, and then that material cost has inflated between the time that the last cost estimate was done and the time it actually gets built. That happens too. Or, maybe a manufacturer went out of business and then the comparable product to the one that was specified is twice as expensive. So, all different kinds of things happen. And if you've ever had any experience with construction, you know that change orders are kind of a part of the process. Hopefully a small part of the process, but the main thing is that the owner needs to approve every change order. And the change order will be numbered. Now on both RFIs and change orders, there may be additional drawings that the architect needs to do in order to fulfill that change order or the RFI. So if they do, then they will make a revision on the original drawing. They will note that with kind of a revision bubble. It looks like a cloud, like a kind of a fluffy cloud drawn on the drawing. And then they'll send that out to everybody so that they know that that's a revision. And that will be part of the architect's ongoing construction set. And the very last thing is the punch list and closeout. So usually the contractor, before occupancy can take place, and this may even be before the city or whoever is the inspecting authority issues the certificate of occupancy, usually there's some closeout procedures where they need to have a checklist of all of the things that need to be in place before they can hand it over to the owner. Sometimes it's involved in their scope of work and the architect's scope of work. They go through the last several steps that need to happen before they can consider it to be done. A punch list is where the contractor will go through, and typically the owner and the architect will also walk through, and they'll look at all the individual things that they need to fix before they will consider the building done. So maybe there are some maybe they painted the walls and then they installed some equipment, and the person installing the equipment like scraped the wall. So they might put a little like sticker or something. I mean, not the one that sticks permanently, but some little marker that could be removed so that they know that's a punch list item. And you kind of go through the whole building, you collect these punch list items, and then the contractor hopefully fixes all of them, and then you walk through again, make sure that all the punch list items have been corrected, and then they go through like a series of closeout procedures, just kind of nuts and bolts things like making sure that all the doors are operating properly, all of the elevators are operating, as if you're the person who's going to be using it. You kind of go through the building and make sure that everything's working. Do all the faucets turn on? Did they flip the faucets where the hot is cold and the cold is hot? Have they changed out all the locks? Have they done everything that they needed to do? Is the landscaping done if it was supposed to be done? And so the closeout procedures are all of those things that they need to do on the contractor side, on the construction side, before they hand it over to the owner. And usually the architect will be part of that procedure so that if they are noticing anything or they're remembering anything that needs to be included, that they can do that as well. So hopefully this gives you a good overview of what the architect does on a project, what their role is, and you can see that the role of the architect really changes throughout the process because you have to adapt what it is that you're doing to suit that particular phase of the project. Sometimes you're doing more design work, sometimes you're doing more technical work, sometimes you're doing more documentation and drawings and writing, but I think the key here is that you're in constant communication with all of the parties involved on the project. We'd refer to those as the stakeholders. The architect speaking to the contractor and typically the owner a lot, keeping them informed, the subconsultants, and so that everybody's kind of on the same page, moving that project along through that series of phases and through the process so that you can achieve the best result with everyone working on it.